mankind in space exploration, thanks to numerous These days, any person has the opportunity to follow the progress being made by mankind in space exploration, thanks to numerous scientific investigations where found out that the universe is unbelievably enormous and contains a great number of celestial objects. However, in all this diversity, there are only several hundred worlds that we know of which resemble our planet. In the Milky Way alone, the number of exoplanets is supposedly over 1 trillion. And now, I invite you on a journey to the most amazing exoplanets ever discovered by now. The first exoplanets were discovered back in the late 1980s. Since then, the number of detected ones has increased hundredfold. According to statistics from January 2021, over 4,000 planets in other systems have already been discovered. Apart from these, several thousand candidates likely to be given this status have been registered. With sufficient evidence from Earth-based observatories, most of them are going to become officially confirmed exoplanets. The overall number of planets in our galaxy may supposedly be over 1 trillion. From 5 to 20% of these are close to our Earth in terms of their size and composition. Not all of them are in their host star's Goldilocks zones, that is, not all of them are habitable. Still, according to scientific estimates, there are not less than 300 million potentially habitable planets in the Milky Way. Exoplanets differ very much in terms of their environment. Their dimensions may be enormous, some even beating Jupiter, but there are also comparatively smaller ones, close to our Earth in size. Some of these bodies are hot, consumed with oceans of molten lava, whereas others are encased in a shell of permanent ice. There are planets out there made entirely of oceans, with not a bit of dry land on them, while on others, sulfuric acid rains or diamond snow are irregular occurrence. Various techniques are used for discovering other worlds. As a rule, it is next to impossible to spot an exoplanet by simply looking through a telescope. That is why in 2009, Kepler was launched, the first space telescope designed for searching for planets beyond the boundaries of the solar system. The telescope's cameras had 42 charge-coupled devices, or CCDs, with a total resolution of around 96 megapixels. With a field of view covering about 25% of the sky, and coupled with a 1.5-meter mirror of the telescope, it was able to detect astronomical bodies within 3,000 light-years from the Earth. In the 3.5 years of productive operations, Kepler managed to spot over 3,500 exoplanet candidates. The status of over 2,000 of these has already been confirmed by repeated observations. It was in this period that the smallest of known exoplanets today was detected. The diameter of Kepler 37b is just 35.7% that of the Earth. The telescope was also instrumental in registering several stars and brown dwarfs. The transit method was used by Kepler in the search for exoplanets. This method is based on observing the star's luminosity. If the supposed planet passes between the parent star and the observer, this will be noticed in the telltale decrease in the star's luminosity. The extent of these fluctuations in luminosity directly depends on the ratio of the star's and planet's dimensions, while their regularity allows one to estimate the object's orbital period. The transit method requires accuracy in measurements. Changes in a star's spectrum account for less than 2% and are usually tenths or even hundredths of 1%. Ripples in the atmosphere, dust and precipitations negatively affect results produced by Earth-based telescopes. That is the reason why telescopes based on automatic space stations are used for searching for objects beyond the boundaries of the solar system. Unfortunately, in 2013, 3.5 years into the mission, the Kepler Space Telescope had several major equipment failures. In 2018, the spacecraft ended science operations completely. Kepler was the first spacecraft to be created specifically for looking for exoplanets. However, most of the objects it managed to spot happened to be too remote and dim to study them in any satisfying detail. That is why the next space research complex had slightly different parameters. Kepler was succeeded by the TESS telescope launched by NASA on the 18th of April 2018. Its main object was searching for rocky exoplanets orbiting the brightest stars within 200 light-years from the Sun. This telescope also used the transit method, and here is the spacecraft's brief profile. TESS is equipped with 4 refractors with a 24 by 24 degree field of view and a 10 cm aperture. The spacecraft's peculiar orbit allows it to cover both the northern and the southern parts of the sky, which is approximately 85% of the entire sky. Photos are taken by 4 cameras, and the resolution of each camera's CCD is 16.8 megapixels. TOI 700D is one of the most notable objects discovered by TESS. This exoplanet became the first object of the kind comparable to the Earth in size, and which found itself in the habitable zone of its star. It orbits TOI 700, a red dwarf lying slightly over 100 light-years away from the Sun. It is a small and rather cold star. Its temperature is half that of the Sun, and its mass and radius are just 40% those of the Sun. TOI 700 is peculiar for its high stability. Not a single flare has been registered on it since the beginning of observations. A star's stability is a positive feature, because bursts of activity are able to divest its planets of their atmospheres and be generally pernicious for potential life on planets' surfaces. There are at least 3 planets orbiting TOI 700. The one closest to it, TOI 700b, is comparable to the Earth in size. Its mass is approximately 1.07 times that of our planet, and its radius differs from that of the Earth by not more than 2%. Unfortunately, TOI 700b is too close to its host star. It is within about 0.06 astronomical units, and a year on the planet lasts just 10 days. In addition to that, chances are it is tidally lopped, that is, it faces the star with one and the same side. This means that the planet is likely to be scorching hot. The planet lying further from its star, TOI 700c, is thought to be a mini-Neptune. Its mass may be from 5 to 13 times that of our Earth, and its radius is 2 or 3 times that of the Earth. It takes TOI 700c 16 days to complete one orbit around its host star. Located closer to the star than the inner border of the habitable zone, it must be too hot for life to originate and evolve there. TOI 700d is the third, and at this point the remotest planet in the system discovered by now. It takes 37.4 days to complete a full orbit, which by the way lies along the inner edge of the habitable zone. The mass of TOI 700d hasn't been gauged precisely, and may be anything from 1 to 3 times that of the Earth. At the same time, the planet's radius is just 20 to 30% bigger than that of the Earth. TOI 700d is thought to be a rocky world, but its exact composition is not yet known. The amount of energy received by the planet from its star is 86% that of the amount we receive from the Sun. Assuming the planet's atmosphere is similar to ours, the steady-state temperature on the surface of TOI 700d is estimated at 268.8 Kelvin, or 4.3 degrees Celsius below zero. However, due to the greenhouse effect, or other features of the atmosphere we may not know yet, this figure may shift either up or down. There is no precise data on the eccentricity of TOI 700d, but it is thought to be small at around 0.11. As the planet's orbit finds itself at the inner edge of the Goldilocks zone, the planet's eccentricity, however small, may incidentally turn out to be perceptible when the planet comes too close to its star from time to time, thus actually leaving the habitable zone. Still, with a year on the planet lasting slightly over 1 Earth month, such unfavorable periods are expected to be rather short. If there are living creatures on TOI 700D, then they might be able to weather the harsh spells in a state of anabiosis. Alternatively, they could adapt or migrate to less inclement areas. Even though the data acquired by spectral analysis of TOI 700D can't be enough for making conclusions, there is a chance that there is liquid water on the planet's surface. Then there is bound to be the greenhouse effect too, which will help the surface temperature to reach favorable values. As I've already mentioned, TOI 700D, along with the other known planets in the system, is highly likely to be tidally locked to its star. If this is the case, there should be a stark difference in temperatures between the sunny side and the shadow side. This contrast could be leveled off by a dense atmosphere, but that would cause powerful hurricane winds. Although the main mission of TESS has been accomplished by now, it still has enough resources to carry on operations. The telescope will continue taking snapshots of the sky, including the Milky Way plane, which is the most challenging direction for observation. Over 2,100 exoplanet candidates have been discovered by TESS in the course of the main mission. Not less than 66 of them have already been confirmed. Apart from that, 6 supernovae flares have been registered, 3 exocomets identified, and a great number of photos taken of small bodies in the solar system. The latter were not objects of the main mission, but are of course of scientific interest. TOI 700D is still guarding its mysteries and waiting for its explorers. Great hopes are placed on the new orbital telescope James Webb, which may help investigate this world and a number of other ones. The new telescope is supposed to provide images of not only exoplanets lying closest, but also detect their moons and carry out spectral analysis of their surfaces. The launch of the telescope is planned for the 31st of October 2021. If all goes according to plan, first data will be available as soon as next year. Will we ever discover a world that could rightfully be called the second Earth? And if we do, will we be able to reach it? Distances in space are just too much for humans. Could it be that we're confined to the limits of our system forever, allowed only to gaze at the vast, infinite universe? Several centuries ago, it was quite unimaginable to admit of discovering exoplanets. However, everything changed. In 1992, as the Polish astronomer Alexander Wolszczyn was studying the pulsar PSR 1257+12, it was noticed that its pulsation period was irregular, which was accounted for by the influence of 2 planets with a mass 4 times that of our Earth. This hypothesis was later confirmed, which led to the conclusion that the first planetary system beyond ours had been discovered. There are 3 objects in that system, 2 of which have a mass similar to that of the Earth, and are comparatively close to their pulsar in the constellation Virgo, due to the fact that it is rather remote from us, and the conditions for sustaining life are poor. The PSR 1257+12 system is of little interest to scientists, although its discovery led us to believe that the search for Earth-like worlds may eventually be a success. Just 3 years later, the first exoplanet orbiting a Sun-like star was discovered 50 light-years away from the Earth, and was dubbed 51 Pegasi b. Just several years later, the number of confirmed exoplanets counted dozens, and today, 4,173 exoplanets in 3,096 different planetary systems are known to science. In addition, a great number of Earth-like objects is still awaiting the confirmation of their status, which is possible after a secondary registration with telescopes on Earth. The number of celestial objects of this kind in the entire Milky Way may well be over 100 billion, with about 1/5 of them bearing resemblance to our Earth. Interestingly, most of the discovered Earth-like exoplanets are located not very far from our system. Ross 128b, This planet was discovered in 2017 by European scientists with the help of the High Accuracy Radial Velocity Planet Searcher, or HARPS, at the observatory in Chile. The object is located in the single star system Ross 128, which is the 13th closest star to us. The object is a faint red dwarf with a mass of 0.15 that of the Sun. It was possible to discover this planet thanks to its gravity, which leads to minor variations of the stellar spectrum of its parent star. While observing these variations, HARPS is able to spot planets around stars. In this particular case, it took the telescope approximately 10 years to collect sufficient data before discovering this planet. This effort paid off. Ross 128b became the second Earth-like exoplanet lying closest to us. It is located 11 light-years away from the Earth in the constellation Virgo. Apart from that, astronomers claim it to be the most moderate of all known exoplanets, due to its mass, its temperature, and its rather calm parent star. It takes this planet 10 days to orbit its star. It finds itself in the habitable zone, since the temperature of the photosphere and luminosity of Ross 128 are low. It is also classified as an Earth-like type of planet, and at the moment, Ross 128b is one of the most likely candidates to be a potentially habitable exoplanet. Besides, research done in 2018 confirmed that its climate is favorable enough to sustain life. Another exoplanet on the list of Earth-like objects located closest to us is Gliese 667cc. This celestial body is part of the triple-star stellar system Gliese 667 in the constellation Scorpius. It consists of 2 orange dwarfs and 1 red dwarf. The first 2 components, A and B, lie 12.6 astronomical units from each other, with the third component orbiting them at a distance of 230 astronomical units. The Earth-like planet in this system was discovered on November 29, 2011 in the Geneva Observatory with the help of the Doppler method. The object is 22.7 light-years away from the Earth and is the second exoplanet orbiting its host star. The mass of Gliese 667cc is about 3.8 times that of the Earth, while its temperature range may be rather similar to the terrestrial one. Modeling at the Planetary Habitability Laboratory managed by University of Puerto Rico reveals that the average surface temperature of the atmosphere of Gliese 667cc must be approximately 27 degrees Celsius. The planet receives about 90% of energy compared to that received by the Earth from the Sun. Also, Gliese 667cc is almost certain to be locked in its orbit, that is, it faces its star with one and the same side. If the planet's orbit does not curve too little and if its mass is not too big, the greenhouse effect produced by the rather dense atmosphere must be quite sufficient to create favorable conditions for primitive life forms. The next deserving object on our list is HD 85512b, an exoplanet orbiting the orange dwarf HD 85512 in the constellation Vela. Its star is a single K-type main sequence star with a mass 0.69 that of our Sun. As for its age, it is more than 5.6 billion years old. The exoplanet discovered close to it is located 36 light-years away from the Earth, and its mass is 3.6 times that of our planet. At the same time, HD 85512b may be one of the smallest planets in the habitable zone. It was spotted in August 2011 with the HARPS telescope. The supposed steady-state temperature of its surface is something around 25 degrees Celsius. If the planet's atmosphere is identical to that of the Earth, its surface temperature should reach 78 degrees Celsius. It is also highly probable that there is liquid water on this celestial body, which is why for some time it was believed to become the most likely place where life would be discovered first. Apart from the objects mentioned, there is a number of other celestial bodies in space located quite close to us, which also boast some unique features. Many of them may well contain various life forms and may be not quite as far from us as we would imagine. However, we should bear in mind that some half a century ago man did not possess a tenth of information known to us today, and in the future the progress of our discoveries is going to escalate even more dramatically. For example, on December the 18th, 2019, the Cheops Space Telescope was successfully launched in orbit by the European Space Agency. It is specifically aimed at exploring exoplanets using the transit method. It may be this spacecraft is to contribute to the list of Earth-like exoplanets, and it may become the telescope to first discover alien life forms in the universe. Science does not stand still, and every new day bears witness to the fact that mankind continues to actively stride forward. If this progress does not lose its momentum, sooner or later we're bound to find an answer to the eternal, mind-perturbing question: are we alone in the universe? And I hope the answer we get will prove that life is not a mere accident, but a logical consequence of the evolution in our universe. The discovery of this object was made with the Kepler Space Telescope, whose mission was to look for exoplanets. The Kepler star system became the 90th object spotted by the telescope. That is where the catchy nickname Kepler-90 comes from. Let's take a closer look at it. Kepler-90 is a yellow dwarf of spectral type G0V. Both its mass and radius are approximately 1.2 times those of the Sun. As for the surface temperature, it equals 6080 Kelvin, or 5800 degrees Celsius. The estimated age of the star is 2 billion years. This makes it 2 times younger than our Sun, which formed about 4.6 billion years ago. It was possible to gauge the star's age by analyzing its spectrum, which helps establish the stage of the star's evolution. Another method instrumental for the purpose is observing stars lying closest to the object under scrutiny. Incidentally, Kepler-90 is too dim to be seen with the naked eye. Its luminosity, meanwhile, is approximately 1.7 times as intense as that of the Sun. Located in the Draco constellation, it is approximately 2,840 light-years away from our system. Incidentally, the object is hardly notable for its properties. It is quite an ordinary main-sequence star, without any particularly exciting features. It's the number of planets discovered in its system so far that makes it really stand out. The only other system where we could observe as many as 8 planets had been only our solar system. Before Kepler-90 had been spotted, the Sun held the first place in terms of the number of planets, with the following champions as the runners-up: the system's TRAPPIST-1, HD 10180 and HR 8832. Each of them has 7 detected planets. At first glance, Kepler-90 might probably look like our solar system in miniature. However, on closer inspection, the following principal differences will change the observer's mind about it. For a start, the smaller planets are closer to the star, with the bigger planets lying further and following bigger orbits. As we know, it's quite the other way round in the solar system, with the giants close to the star and the smaller planets located further away. Admittedly, it is too early to claim this with absolute certainty, and the number of planets we know of in the Kepler-90 system may increase as scientists make progress in their observations. Another principal difference from our system shows in the planets' mutual proximity. The Earth and the other planets in our system, on the other hand, are located further away from each other, and also, all the 8 known planets in the Kepler-90 system orbit their star within just 1 astronomical unit. Another important difference is the fact that 6 internal planets in the Kepler-90 system are either super-Earths or mini-Neptunes in size, while its 2 outer planets are gas giants. The 2 planets in the system lying closest to their host star, dubbed Kepler-90b and Kepler-90c, may probably be called our Earth's analogues. However, their temperatures are considerably higher than on Mercury or Venus. That is, the 2 planets closest to their host star in our solar system. This is the case on account of their proximity to their system's center. Kepler-90g and Kepler-90h are the objects lying furthest from their parent star. Both of these bodies are gas giants. Their dimensions must be comparable to those of Jupiter. The system leaves the general impression of being extremely compact. Even Kepler-90h, the remotest planet in the system, lies approximately as far as the Earth does from the Sun. Also, as I've already mentioned, this remotest planet is also the largest in the system, and a year on it is almost as long as a year on our Earth. 331 days to be more exact. All these planets were discovered not so long ago, with the latest of them, Kepler-90i, spotted as recently as in 2017. It was possible to detect it with the transit method, that is by observing sharp changes in the host star's luminosity when one or several planets pass across its disk and block a certain portion of its rays normally visible to us. This method is quite productive for large celestial objects lying close to a star. However, if a planet is remote from it, fluctuations in the star's luminosity and other incidental factors interfere with observations. These problems may be dealt with in 2 ways, namely by prolonging observation periods and by sorting data with the help of statistical algorithms and artificial intelligence systems. In fact, the latter helped the team of scientists studying Kepler-90 in discovering the 8th planet in the system. A specially trained neural network was instrumental in pinpointing one more planet in the Kepler-90 system and defining its parameters. The newly spotted object was given the temporary designation Kepler-90i. Located between Kepler-90c and d, this celestial object orbits its star within less than 15 days, and its radius is 1.32 that of the Earth. Kepler-90i is 3 times closer to its star than Mercury is to the Sun. That is why its surface temperature is rather high, approximately 427 degrees Celsius. Just to compare, this value is quite close to the surface temperature of Venus, which is 477 degrees Celsius. Kepler-90i resembles our Earth very much in terms of its chemical composition, size and mass. Its orbital period is 14.4 Earth days. As the planet lies too close to its parent star, it cannot realistically support life. The discovery of this celestial object prompted a lot of questions on the part of the scientific community. It still remains to be found out how such a large and complex planetary system managed to remain so compact and stable at the same time. Also, astronomers assume there might be more planets out there orbiting Kepler-90, which still remain to be discovered. The search for other bodies in this system is still on. As for the other known planets in the system, the parameters of each are unique in their own way. Let's have a look at them, starting with the planet closest to its star. The radius of the one nearest to its parent star, Kepler-90b, measures about 1.3 times that of the Earth, and its orbital period lasts for 7 days. Just like all the other objects in the system except Kepler-90i, it was detected back in 2013. The planet coming next, orbiting its parent star slightly further away than Kepler-90b, is Kepler-90c. Its radius is slightly smaller, measuring 1.19 times that of the Earth, and as for its orbital period, it is 8.7 days. The 4th known object in terms of its closeness to its star is Kepler-90d, with its radius measuring 2.87 times that of the Earth. It orbits Kepler-90 within a period of 59.7 Earth days. Kepler-90e holds the 5th place. Its radius is 2.66 that of our planet, and its orbital period may reach 91.9 days. Kepler-90f comes next. Its radius is 2.88 times that of the Earth, and its orbital period is 124.9 Earth days. After Kepler-90f comes Kepler-90g with a radius measuring 8.1 times that of the Earth. Its orbital period is 210.5 days, and its mass is approximately 0.8 times that of Jupiter. Last but not least, but definitely the remotest from its star at this point, Kepler-90h has a radius measuring 11.3 times that of the Earth. Its orbital period is 331.6 Earth days, and its mass is about 1.2 times that of Jupiter. As this object's orbit lies approximately as far from its star as that of the Earth from the Sun, assumptions about the presence of hypothetical moons in its environs may prove to be true. If there are any located close to Kepler-90h that are similar to Titan or Ganymede in their parameters, conditions on these moons may be realistically suitable for life. These hypothetical celestial objects might have some really incredible features. As their planet lies in the habitable zone of its star, some of these moons may well resemble our Earth, for all we know, just as you're watching this video on the Cosmo channel, and new life may be dawning on a moon of the faraway gas giant Kepler-90h. This is a kind of landscape one would see in the least harsh part of a planet dubbed by scientists as Super-Earth, and the closest potential candidate suitable for searching for alien life forms. But let's be consecutive. The recent past heralded a boom in discovering exoplanets. There are 4,370 exoplanets discovered in over 3,000 planetary systems so far. In addition to these, more than 3,000 objects are awaiting confirmation of their exoplanet status. Most of them are large bodies, gas giants, super-Jupiters and super-Earths. This is accounted for by technical features of the technologies used for the purpose. It is easier to look for massive bodies with a short orbital period than to try to spot smaller planets similar to the Earth or Mars in terms of dimensions. There are among exoplanets those that may realistically harbor life. There are dozens of these objects scattered in space, and they understandably draw scientists' close attention. Today we're going to look at one of these objects, which is an exoplanet dubbed Gliese 832c. In fact, this exoplanet is one of the most likely places where alien life forms will eventually be detected. This exoplanet orbits a star called Gliese 832, which lies 16 light-years away from the Sun and is part of the Grus constellation. Gliese 832 is a dim red dwarf whose luminosity is just 0.7% of that of the Sun. Both its mass and diameter are approximately 2 times smaller than those of the Sun, and its temperature reaches about 3,300 degrees Kelvin. That is the reason why the habitable zone of this planet is within quite a short range from its star. Due to tidal forces, the planets lying in the habitable zone of Gliese 832 will be tidally locked to their star, that is, will face the star with one side only, just as it is the case with the Moon and the Earth, and Mercury and the Sun. There are 2 confirmed planets orbiting Gliese 832. The Jupiter-like planet Gliese 832b was discovered first. Astronomers announced the event in 2008. With a mass 2/3 that of Jupiter, the planet orbits its parent star at a distance of an average 3.4 astronomical units, completing a full orbit every 9.4 Earth years. The discovery of the other confirmed planet, Gliese 832c, was announced in 2015 by an international team of scientists headed by Robert Wittenmeyer. It got an exceptionally high rating for its similarity to the Earth, 0.81 to be more exact, which instantly attracted both scientists and reporters. It was also nicknamed the Second Earth, even though the 2 planets' parameters are rather different. Either way, this is one of the planets closest to the Earth with such a high Earth similarity index. The mass of Gliese 832c is 5.5 that of the Earth. It takes the planet 35 Earth days to complete a full orbit around its parent star, moving at a distance of an average 0.16 astronomical units. This is 6 times less than the distance between our Earth and the Sun. Its orbit's eccentricity is rather high, with the planet regularly leaving the habitable zone and then re-entering it. This must cause sharp temperature leaps and drops on its surface. Gliese 832c is estimated to receive approximately as much energy flux from its parent star as does the Earth from the Sun. The average surface temperature on the planet is 253 degrees Kelvin or 20 degrees Celsius below zero. It is also suggested that due to the atmosphere, which is likely to be quite dense, the temperature on the planet may be considerably higher. However, it is not easy to claim this with certainty, as Gliese 8